All right, let's dive right in. Today, we're talking about a fundamental force that powers nearly everything around us, from the phone in your hand to massive industrial cranes. It's this invisible, super powerful link between electricity and magnetism. Let's peel back the layers and see how it really works. So really, this whole thing, it all comes down to one big question. How can the electricity flowing through a simple wire generate the very same invisible force that makes a compass needle spin? Let's find out. But before we get into the how, let's just take a second to appreciate the wow. Get this. The strongest electromagnets that we can build can create a magnetic field 10 million times stronger than the Earth's. That is an insane amount of power. And it's all created just by running an electric current. Okay, so how on earth do we get to that kind of power? Well, first things first, we need a quick refresher on the basics. Let's talk about magnetic fields. So what is a magnetic field anyway? You can think of it as this invisible bubble of influence that surrounds any magnet. If any magnetic material, like a paperclip, wanders into this bubble, it's going to experience a force. You can't see the field itself, but you can absolutely see its effects. Right, so if we can't see it, how do we even talk about it or map it out? Well, we use a pretty clever tool to visualize it, magnetic lines of force. Think of these as a roadmap of the magnetic field, showing us exactly which way the force is pointing and how strong it is. And these roadmap lines, they follow some very specific rules. Check this out. First, they always point in the direction the force is going. Second, they form complete unbroken loops. They never just stop in the middle of nowhere. And third, just so we're all on the same page, we always draw them traveling from the magnet's north pole to its south pole. This gives us a really consistent way to map out any magnetic field we encounter. Okay, so we've got the magnetism part down. Now let's bring in the other half of our power couple here, electricity. This is where things get really, really interesting. This is where we see how these two forces connect. And here it is. This is the big one, the absolute key to everything we're talking about. Anytime an electric current flows through a conductor, a material that lets electricity pass through, like a simple copper wire, it generates its very own magnetic field. That's wild, right? Electricity doesn't just create power, it literally creates a force field. And that brings us to our star player, the electromagnet. It's a magnet that isn't naturally magnetic. Its power comes 100% from an electric current. No current means no magnet. It's really that straightforward. Now, this is what makes an electromagnet so special. Think about a regular permanent magnet, like one on your fridge. It's always on and its strength is fixed. But an electromagnet? You can switch it on and off in an instant. And, as we're about to see, you can precisely control its strength. That control, that's the real game changer. Which, of course, brings us to the next logical step. If we can create a magnet with electricity, how do we make it more powerful? How do we go from a weak little field to one that can literally lift a car? So yeah, let's just ask it straight up. We know we can turn it on and off, but what factors can we actually change to control its strength? Turns out it's surprisingly straightforward. There are really two main ways to boost the power of an electromagnet. The first is all about the electricity itself, and the second has to do with the material we decide to place inside the electrical coil. And this chart lays it out perfectly. It's all about cause and effect. Want a stronger magnet? Increase the current. More electricity flowing through the wire equals a stronger magnetic field. Simple. Want to make it even stronger? Add an iron core inside the coil. The iron acts like a lens, gathering and concentrating those magnetic field lines, which makes the overall force much, much more powerful. So we've seen what an electromagnet is, and we've seen how to control it. Now let's just step back for a second and appreciate why this is one of the most important concepts in all of modern technology. If you remember just one thing from all this, let it be this. An electric current creates a magnetic field that we can control. We can turn it on, turn it off, and adjust its strength on the fly. This single principle is the foundation of electric motors, speakers, hard drives, and countless other technologies that basically define our modern world. And that leaves us with a final thought. This hidden force, born from this beautiful relationship between electricity and magnetism, already powers our civilization. So the question is, as our understanding grows, what happens when we completely master it? What new technologies will we unlock? Now that's something to think about.